Just very, very quickly, for those of you that don't know, LNEG, the National Energy and Geology Laboratory. So we work both on energy and geology, and you can see there in a very quick nutshell the different areas of activity that we work. And actually hydrogen very nicely covers and touches several of these activities, from natural hydrogen that exists underground to underground storage of hydrogen possibilities that we also have know-how here, to using actually biomass or waste to produce hydrogen, also using renewable energy for feeding, electrolysis processes, and even things like what we do here at the Resource Economics Unit, where we try to calculate the competitiveness of hydrogen being produced in Portugal, what costs will it have, and where it's going to be consumed and how it can be consumed in different economic activity sectors. At the National Energy and Geology Laboratory, we've been working in all of these different areas. And also, if you see there the little symbol with geo information, we've also been looking at the different geographically explicit locations in different activities. And we have also a hydrogen atlas where we look at different areas of Portugal and where you can produce and consume hydrogen. So if we move into the next slide, this session is actually structured in two parts. The first part that I'm talking, and the one with Juan that is going to go in detail into the levelized cost of hydrogen tool. And in the first part is going to be shorter. I'm just giving you this brief introduction on the tool. You can already make some questions at that point. The second part, we really go into detail into the tool. We probably go also online to check how the tool is structured and how you can actually use it with a demonstration. So it would be a very good moment for those of you that really want to use it to actually see it live and make questions. Very quickly, what is this LNEG levelized cost of hydrogen tool? And why it was developed, under which scope it was developed. It's part of Research and Resilience Program agenda, and it's called the Moving to Neutrality Agenda that has a lot of Portuguese companies and research institutions. It's you can actually find some information on it online. If we go on the next slide, this is an agenda that has actually a hydrogen as a core point, but hydrogen is there not as a standalone. We are looking into hydrogen as a center point to be used to produce hydrotreated vegetable oil, to be used in road fuels, as a road fuel in road transport, to produce sustainable aviation fuel for airline companies, for bionafta, and in particular in this project, some of the things we are doing here at LNEG, we are very interested in looking at hydrogen refueling stations. Our role in this very big project, Moving to Neutrality, is divided in, let's say, two blocks. Block A is looking into technical and economical valuation of hydrogen transport solutions for hydrogen refueling networks. What do we mean by this? Is we are thinking on really looking into hydrogen, how to do we deliver hydrogen to the transport sector? And at this moment, we are really, let's say, transport agnostic, if we can say so, and we look into the transport sector as a whole, but in the back of our minds, we are probably thinking on freight transport and transport, passenger transport, like buses. This is probably what we are thinking of. So in this, what we are doing in this context is we are looking at what are the different hydrogen transport options to make sure that hydrogen gets to vehicles. We are analyzing the cost structure of these various options. We have created the LNEG levelized cost of hydrogen tool, And we are working on fuel supply curves for Portugal to make sure hydrogen gets to this type of end-use consumers for the current period, 5 years from now, and then the long period, because we know hydrogen technologies and transport solutions will evolve. And of course, we do what we call a pastel analysis, which is basically looking to the different components from just not only a technology point of view, but also things like social acceptability, regulation, environments, etc. Block B is basically looking at the impacts of having, let's say, cheap liquefied hydrogen available. At the moment, liquefied hydrogen is expensive. What if we could have much cheaper liquefied hydrogen available? What would this mean for the competitiveness of hydrogen, not only in Europe, in Portugal, sorry, but also what would this mean for hydrogen of Portugal, to not only to satisfy our needs in our economy, but also what would this mean for our hydrogen in the European energy system? Today we only talk about one of the things we are working on, which is the LNEG levelized cost of hydrogen tool. So very, very simplified. This was something that was developed here at the National Energy and Geology Lab, and it's available online, and it can be created, it can be tested by you. This was something that was available made available online in December already last year. It was a beta version. It has been tested already, and some bugs have been encountered. They have been corrected. And if you still find some bugs and some incorrections, please do let us know, because we are still very open and eager, of course, to correct it and make it better. So thank you for that. So why do we have this online? Well, the idea is to provide you, all of you, a free service that will allow you for the quick estimation of costs over the different components of the hydrogen value chain. And I'll explain what this means. So that's the website where you can go and use it. Why do we do this? There's already some levelized cost of hydrogen tools online. Well, for the first thing, it's specific for Portugal. It does consider specific features of water availability for Portugal, the wind and solar features to produce renewable electricity for the Portuguese case. Some of the cost data, not all, but some of the cost data are really specific for Portugal. It is the first levelized cost of hydrogen tool that we are aware of that includes the various components of the value chain. Most of the ones we know, they only consider the production of hydrogen. We go all the way to getting hydrogen to the end user, although our end user is the transport sector. So, and actually the refueling station, so to fuel the cars. So this would be like in bold, you have the very three most different unique characteristics. It's modular, so it means that you can choose to use just one of the modules. It's flexible. You can use it with default values or input your own. Let's say you want to test your specific projects. You can change the default values by your own, and it's scalable. And it's free. It's available for free because we are a state laboratory, so we do public service. So if you move to the next slide, so this is what we mean by the hydrogen value chain. You see it starts there on the upper left corner. We have renewable electricity, which is wind and solar. We also have offshore wind in the tool, if I'm not mistaken. This electricity can supply electrolyzers. The only production option we have is electrolysis, water electrolysis. This electrolysis can also be input with electricity from the grid. So it's not just 100% renewable electricity. A note there is that we consider water abstraction in treatment costs and also renewable electricity production costs. And Juan will tell you in the second part exactly what parts water costs. are considered. Then you can decide to stop there and just calculate the costs, the production costs only there, or you can be, more, let's say, more demanding, and you take it one step further and you decide you want to liquefy your hydrogen. What if you want to have liquefied hydrogen because it's easier to transport? So you can add the liquefaction costs and calculate the costs for that. Or you could bypass liquefaction and just go into storage, hydrogen storage costs. Then after having it stored, you can consider costs to transport your hydrogen, and you can define a distance for transport. You can decide to transport by trucks or by pipelines, or maybe a combination. And then you have the refueling station, and you can decide to some extent the size of your refueling station. Again, you can have only one of these modules, or you can have the whole, go all the way until you go to the refueling station. As far as we know, the LCOH tools that we know freely available, they normally stop in the production step. So as we say, the mindset is to deliver it to the transport sector, but we are not calculating costs after the refueling station. So we stop at the refueling station. So the idea is that from there, you could take your bus, your truck, and maybe even your car to the refueling station. So the next slide is basically to show you this is how it looks like. If you go online, you have there the QR code. So you can immediately take a look. It's now hosted in our website. It's part of the LNEG's website. It's in 2 languages, so I'm here speaking in English, but everything is in Portuguese. There is a report, a detailed report that explains as best as we can how everything is calculated and all the inputs. And yeah, it's a living tool. As I said, we are very willing and open to, if you find bugs and you find mistakes, tell us, we fix it, and we are still open to some extent to make it better, more detailed. So please, we invite you to try it and let us know what you think of it. Yeah, so this is just also to emphasize what I was saying before. Not only you have this website, you can test, but there are 2 versions of a report, maybe a bit boring, sorry for that, where you find all the assumptions on the costs that you will calculate. And you have it both in English and in Portuguese. So I think that's it from my side. And if someone already has some questions or comments, this would be the perfect moment for you to raise your hand or just let us know, or unmute yourself and tell us what you think. So I think no one has any questions or comments. I don't see anything on the chat. I don't see people unmuting themselves. So this means I will pass the word to Juan, and now you will go into the in-depth part, right, of the levelized cost tool. Thanks, Juan.
Yeah, thank you very much, Sofia, and nice to have you all here in this session. That was a very nice overview of the tool, and now we are going to deep a little bit more in what and how actually the tool works and how we can use it in our benefit. Okay, so this will be related to the demonstration of the tool. And I would start with the definition, our view from our perspective of what the levelized cost of hydrogen is, and it is normally shortened as LCOH. So the levelized cost of hydrogen is a metric itself that helps us to compare different projects or different investment options that involve hydrogen, of course. And this same metric can be transformed somehow in levelized cost of energy and compared with other projects. These metrics also serve, besides try to evaluate a whole portfolio of projects, then these metrics help us also to analyze or to assess the feasibility of one project. It is also a method that involves the inventory of all the expenses over the lifetime of the project in order to, let's say, create the concept of the levelized cost of hydrogen that at the end reduces to the minimum price of hydrogen that must be at which we must sell the hydrogen in order to fulfill all the requirements in terms of returns on our investment or projects. Okay. How this levelized cost of hydrogen is calculated? Well, in here I present the basic general equation that is widely used for the levelized cost of hydrogen. In here we have the capex. Better said, in the numerator, which is the upper part of the equation, we have all the costs, okay? And in the denominator, we have all what is associated to the annual hydrogen production. But the particular thing with this equation is that all the expenses that we incur over the years are somehow translated into a reference point. And we will see it in the next slide graphically so you can understand better what I'm saying. Also, it happens with the production. So the capex in this case represent the capital expenditures, and these capital expenditures are all the expenses that are required to put into operation any hydrogen project or hydrogen-related project. For instance, the equipment, the pipes, the civil works, the mechanical works, electrical works that we need in order to commission the project to start operations. The OPEX means in here operational expenditures, and we have divided these into two parts. One that is related to the fixed operational expenditures, and when I say operation, it also includes maintenance. For instance, the rent of the building, the salary of the people, or all these administrative, let's say, costs that are fixed, that are certain, are usually put into a term that we call operational expenditures fixed per year. The variable operational expenditure depends on production parameters, for instance, how much hydrogen I produce. And in here we put, for instance, the electricity, the amount of water that is needed, the amount of fuel, if we are transporting, for instance. Those are operational, variable operational expenditures. We have another variable operational expenditure that is the stack replacement of the electrolyzers, which is an important part in this overall levelized cost of hydrogen. In that sense, we have split this variable operational expenditure into water, electricity, fuel, and also we have the stack replacement costs. Because they vary on time, these costs are the replacement of the stack is not done every year, for instance. It depends on the technical, let's say, characteristic of the stacks and the degradation rate of the stack. The annual hydrogen production is subject to the degradation of this stack, and it is also considered within the tool. And this annual hydrogen production, besides of being subject to this degradation, so every year I produce a different amount of hydrogen, it is also discounted as it is done with the OPEX in here, subject to a discount rate. That is this R that is in here, and this discount rate may represent the rate, an internal rate of return of the investment. Okay, it may represent a weighted average cost of capital and a mixture, let's say, of equity and money that is lent from banks. This rate is up to the person or the company who is evaluating a specific project. Okay. And this N that is over here represents the year of this amount of hydrogen that is produced or these operational expenditures. What is not represented in this equation is the decommissioning costs, and these decommissioning costs usually are taken into account and they occur at the end of the life life of the project or the asset. So if we are talking about 20 years, 25 years, then these decommissioning costs are imputed in year 25 at the end or the last day of year 25. And these costs should be also translated into a reference point. And there are artificially ways in order to include it. If you have questions regarding this, we can discuss it at the end. Okay. What is the output, the unit output of this levelized cost of hydrogen? It is normally expressed in euros per kilogram of hydrogen, or euros per kilogram simply. Okay. This, as I said before, can be translated into euros per megawatt hours because the hydrogen has specific energy content, and we can make this conversion. Here is a graphical representation of what the levelized cost of hydrogen is, or more or less the way it is, let's say, computed. So we have a reference time. In our case, is 00 hours of day one of the operation, of the start of the operation of the plant or the project or the set of assets. Okay, so this T-series here represent that reference time. We assume that the capex are, let's say, spent overnight, which is not true, because we have been working on a project since 7 years before, okay? But we translate those costs also to that point. And in here, we will have our capex. But in order to compute the levelized cost of hydrogen, we need all the expenses over the years, the different years, and you can see here, year 1, year 2, year n, 25 years, 30, whatever, okay, need to be somehow translated or put it into the same reference time. And that is what we do with the discount rate that we selected for the specific project. Okay? What I have said before, but it's important to keep in mind because it's a weird concept, because it takes into account the value of money in time. So the yearly costs or cash flows, depending on the method you are computing these costs, or the free cash flow over the years, are discounted to time T0. That is what I said. But something that maybe is not so intuitive is that the yearly production is also discounted. Because in reality, we have a ratio between the cost in the upper part, okay, and what would be the production times an average selling price. That is why this levelized cost of hydrogen at the end reduces to the minimum price we should sell the hydrogen in order to have the expected returns. Okay, let's pass to the demonstration of the tool. And here you have, let's say, a QR code. This presentation will be made available. It is not for you to go to the site at this time. I will go, and I would prefer you to watch the browsing of the site in this webinar. So this is the site of the tool, and you saw a print screen. In here we have, let's say, the definition. This is in Portuguese. I will pass it to English, okay? As you can see, you can switch from one language to the other in the upper part. And in here we have the definition, or what the tool does. How it works is presented in the home page. And here we have 3 different steps. The first one is to choose our modules. To fill in the parameters is the second one. And of course, the third one includes the computation and the view or preview of the results. Okay. And this, as Sofia, my colleague Sofia said, this was sponsored by the PRR program through the Moving to Neutrality project. Before going to the calculator, I will go to the About section, because in here you have the information about the project who sponsored this. Here you have the link of this mobilizing agenda. And what is most important probably for you is to have this section which directs you to the document, to the methodological and description reports, either in Portuguese, either in English. If we go to the contacts, which is the last section of the website, in here you can have an email specifically created for this tool, where we will receive all your inquiries, and we will try if it is possible to implement, let's say, improvements or to correct the bugs that you may find. Okay. As Sofia said, this is a living tool. And in here, we go to the calculator, let's say, section. In here, you can see graphically the 6 different modules that were presented also by Sofia. And the first one is production. I can select this one. I can select liquefaction. I can select storage, road transport, distribution pipeline, or refueling stations. It depends on the configuration of your, let's say, supply chain or value chain, as you want to say it, okay? And depending on this, we will compute, or, well, I will continue here to see the filling parameters, of course, to provide flexibility to the users. We are conscious that a large amount of data and variables should be given or should be open so the users can modify them as they need. So don't be scared, because there is a lot of variables in how this input, let's say, section is structured. So it is structured by module. In here you can see H2 production, H2 liquefaction, storage, and so on. If I go again to the upper part, in the first column we have, for all the modules, parameters or variables, the units that are associated to these parameters, the default values that came from let's say, conversations with companies, also from other sources, and some of them are specific for Portugal. And in here are a set of fields that you can modify according to your needs. So modifying the default values. The default values are always loaded in here, okay? Then we can see for every module that the variables are totally different. For instance, if we go to the refueling station, we have the capex of the refueling station. We may incorporate separately, if we want, the capex of the compression system, but we can include it as it is in the case in here of the default values in the capex of the whole hydrogen refueling station. It depends on you, it depends on the structure of your project and the available information that you may have. In here, we have information about the electricity consumption, and the cost of electricity are associated to the ones that we indicated in the production module. We have OPEX, we have, let's say, the number of hydrogen refueling stations. We can be working with a network of hydrogen refueling stations, as we will see in one of the examples, or only one. Okay, we have the annual discount rate for this module, okay, or for this system, and the lifetime of the hydrogen refueling station. In here, we have set, for instance, for this module, a reference of 20 years. But in any module, in any component, we may have different lifetime of the plant. In here, for instance, which is the second line, okay, we may have a lifetime of 25, the pipelines may be 60, the road transport or the trucks may be 10 years as a span for the lifetime, or 20 for the hydrogen refueling station. We can work on these different, let's say, time intervals, and the tool is able to account for the portion that is of interest to have a levelized cost of hydrogen, an integrated, let's say, overall levelized cost of hydrogen. In here in the production section, we have capacity, lifetime, the discount rates, the type of water, because in here, for instance, we can use fresh water, wastewater, seawater, and we have some reference values incorporated in here in the lower part, these three that are over here, okay? Those are unitary costs for these different types of water that are from a study that we developed like 2-3 years ago, okay? And then these are specific for Portugal. So we can have the replacement period that is normally stated in the manufacturer's data sheet, and it is usually stated in number of hours of operation. We have the mean load factor, and this mean load factor is simply the number of hours in mean that the plant is producing hydrogen in 1 year. So this factor, it means that next number of hours over 8,760 hours in a year, the plant is producing. So we have the production capacity in kilograms per hour per every megawatts that is normally stated in the data sheet of the manufacturers. If it is not stated in megawatts, maybe they give you the whole amount, but you can transform it just divided by the number of megawatts. This is important because this is specific for the production module and is the annual degradation rate of the stack. This is not the percentage of degradation per number of hours. This is the average degradation in 1 year. So it should be somehow translated. If you have 1% per 1,000 hours and you are working 8,000 hours in a year, then is 8% the rate of degradation in that case, okay? So you have CAPEX, you have OPEX, you have the last part of these, which start in here, okay? These four, let's say, rows are associated to the distribution of percentages of the electricity supply to the hydrogen production plant. It means that we may have a dedicated plant of solar that covers 50% of the electricity demand for the hydrogen plant. What we may have 30% that comes from PPAs or the network, okay, and 20% that comes from wind, for a wind turbine or something like that. So we can redistribute in here the different, let's say, contribution of different electricity sources. And this is linked, of course, to different, let's say, costs of electricity for our plant, okay? So we can make this distribution. The liquefaction has the same, some specific parameters that are related to the liquefaction, storage, and road transport. This is for you really to inspect it later on, okay? So the methodological report, as you can see, was recently updated. Probably we will upload another, let's say, update. So it is wise to check from time to time, because we may include more modules, or we may include more examples, or simply corrections of the information that is in the report. Okay. So we go back to the presentation, and in here, I would like now to talk about 4 different examples that we are bringing to you today to compare the levelized cost of hydrogen. In the first one, we use the European Commission levelized cost of hydrogen calculator, and there are some specific data for Portugal that are associated to a 20 megawatts electrolysis plant, and the electricity in this case, for the case A, as we name it, and we will see in the next slides, the electricity comes from a solar PV source. The second case includes a local production and distribution, let's say, network, let's say, units of hydrogen refueling stations. So a production unit of hydrogen of 4 megawatts of electrolysis is linked close by a storage systems of 4.5 tons, and it is, let's say, delivered to one hydrogen refueling station, and everything is in the same, let's say, concentrated area. So no distribution costs are associated to this case. In the third example that I'm bringing here is a centralized hydrogen production that supply a hydrogen refueling station network of 7 hydrogen refueling stations, as you can see here. And this, of course, besides of considering storage systems, which is larger than the one example above, it includes road transport. And the fourth example that I'm bringing today is to demonstrate that if we had the data, okay, we could reproduce the new recently created index of the Iberian market of gas, let's say association, which is IBHYX. This is a new index that was launched in December, and the idea is to compute the levelized cost of hydrogen, which means that would be the minimum selling price of hydrogen. Okay, and this is based on a 50 megawatts electrolysis plant, and the source of electricity comes from 3 different, let's say, portions. A part it comes from dedicated solar PV, photovoltaic, a dedicated small wind plant, and the rest it comes from PPAs or contract power purchase agreements that are signed. The first example then is related to this European Commission levelized cost of hydrogen calculator, as I said before, and this is how it looks like. As you can see, the number of parameters are a lot less. Okay, you can use this one, but ours, the advantage is that we can combine modules, we can include more complexity in the analysis, okay? And in here you have the disaggregation of different things like electricity, OPEX, the grid fees, or taxes, subsidies, oxygen, the sale of oxygen. One of the limitations of the tool that we launched last December is that we are not considering subsidies, because we believe that from now on, the project evaluations should not consider this subsidy, because at the end, they should be self-sustainable. Okay, the result of these default values for Portugal, as you can see here, MPV as a source, using alkaline electrolyzers is 6.14 euros. In this case, is not megawatt hour, is kilograms of hydrogen. Okay, this is the result of our tool. Okay, based on the parameters, equivalent parameters that we come out for our tool, and this is 6.15 euros per kilogram of hydrogen. I will go once again to the site, okay, just to show you in here. This is the website of the tool. We here selected Portugal PV, and you have other options at onshore wind and offshore wind or wholesale, which these options are available in our tool too. The alkaline one, and in here you can see the different, well, what was in the print screen of the presentation, okay? But I want to, okay, I want to show you in here how our tool just worked. I just pre-filled, okay, the parameters in here that we needed. We selected the hydrogen, only the hydrogen production module, because it was the case is only based on that. And as you can see, we fill in with all the information that was in the other tool, and the extra one that was not explicitly stated, like water, for instance. So we decided that we have an estimate that 11 liters per kilogram for this case at a price of, this is fresh water, 3.74 euros per cubic meter. That was added, and then we computed, and we had this value. As you can see here, the graph the pie is dynamic, and you can see more information as you browse over it. And what is not in the other tools most of the time is that you may have an input summary of all the data that you got. You can just copy it, put it into Excel, for instance, and you will have this into a table. Okay? And what we have, in addition, is another piece of information that we believe is very useful for many of you who are working in analysis of or techno-economic analysis and in the use of levelized cost of hydrogen or energy. We have the total levelized cost of hydrogen, but we have also the discrimination of the different, let's say, components in the levelized cost of hydrogen, okay? Which are all these. What we have in addition, the net present values for all these quantities.
Obrigada.
Which is very useful, okay? Sometimes just to verify the values, or if you want to put this into Excel and you are doing a sensitivity analysis or something like that, you may have this. And you have also the annual values that is as output that you can obtain from the output. Okay, going back to the presentation then, that was, let's say, case A. And in here, as I said before, these were the inputs and these are the outputs, and I already demonstrated this live in the website. So in the second case, that is the hydrogen refueling station with local hydrogen production, we have all the data that is needed to be included, and it is, of course, specific from any project. If you are evaluating a project, you will have to gather this information, but there are some part of them that you can assume if you don't have it, and that is widely accepted in different tools, okay? And in here, we have a result that from the production site in here until the hydrogen refueling station, the cost of having all this together without a distribution, without the inclusion of distribution via road transport or pipelines, we have a cost of, based on the assumption, of course, of about 7 euros per kilogram of hydrogen. Okay, remember that this would represent the minimum selling price of the hydrogen if we are the company who is selling, in order to comply with or to get our returns as expected. Okay, the third case in here, I can take advantage now to go again to the site and just go in here to this case, because we can see more information. As we selected various modules, in here is the same graph, okay, that is dynamic, but we have another piece of information for every module. We have the disaggregation of the stack replacement, of the water, how much is the percentage of water over the whole levelized cost of hydrogen. We have the CAPEX, the OPEX, the electricity, the fixed OPEX, the electricity, and so on. In this case, we standardize the structure and we put fuel, but in here in this module, we don't use fuel. Okay, but we use it, for instance, in the transport module. And you have all these for all the modules. And once again, you have the input summary and you have the output summary that you can just copy to Excel, for instance. Okay, so we are talking about prices that are in the order of 7 euros per kilogram in this case. And in the case of having a hydrogen network, a hydrogen refueling station network, this would be the input data. We won't go by that is in the report, and you can inspect it by yourself. But probably what is important to mention or to highlight again is that we may have different lifetimes for different modules. So for instance, the hydrogen refueling station may have a lifetime of 20. The road transport that includes the trailers or the cost of the trailers may, let's say, have a much lower lifetime. And this is taken into consideration in the tool, because when this lifetime ends, we need still 10 years ahead to distribute this hydrogen. And that means that we need to buy more trailers, more trucks, right? And this capital, additional capital that is, let's say, inputted in at the end of this life, then is taken into account in the tool. So in that sense, we believe we are mapping from the production until the hydrogen refilling station. And of course, the cost of this solution is, or this business model is higher, is 8.67 euros per kilogram of hydrogen. Okay, let's go then to this example, and this is of the Iberian index for the hydrogen. They are updating. I just entered just before this, and we have another point in here. The last point yesterday, for instance, was the 4th of March, and now they did it for yesterday. So every Tuesday, I think they are updating these values. Okay, we may go to the website so you can have just a flavor of what is the current price of this index. So this is the same graph, but we have an additional point in here, and we had 585 a week ago, and now we have 588 euros per kilogram. And as I said before, we can transform it into megawatt hours, knowing the calorific power of, or the energy content, better said, of hydrogen, okay? We can reproduce this in our tool, okay? So if I go, first of all, we will have here the production only module activated, because this index only covers production. A 50 megawatts plant, once again, inputs and outputs can be extracted. If we go back, then the parameters that we introduced are slightly different, because, for instance, the annual discount rate was 6 as a reference value for us, because this would represent the weighted average cost of capital. But in this case, we assume they were in the order of 8% in the year, because that is a data that was not provided. Another piece of data that was not provided was the unitary cost for the dedicated PV solar and the wind farm. I will put this in English, okay? And then why? Because they said they provide information about the capacity, they provide information about the CapEx and OpEx, but they don't give the value. They said it's confidential. As we don't have all the details to compute that, we did an estimation internally at LNEG for this example, and we computed the levelized cost of energy for the PV solar, for the wind plant, and these are the results. And in the methodological report, you have the capacity factors that we assumed in order to obtain these values, the degradation rate for the PV solar plant that we assume, because it is not public, that information. Another piece of information that we assumed was this network electricity cost, that in this case represents the portion of the power purchase agreement. And what we did was to take these values and increase them in 20% and distribute it in the relation they stated in the description of their index, which is 70% for wind and 30% for solar. And we got this value that is over here. We believe this is a representative value that reproduces the index. But of course, with actual data, we could have the exact values in here. Okay. I would like to take advantage of this time to highlight that the model that they use in the Iberian market, let's say gas association, they use a more complex model than the one that we are using, and they consider the free cash flows with debt payments over all the lifetime. So using a more simplistic, let's say, model like the one that is embedded in our tool, we could reproduce the index that was obtained more in a more complex way and with a lot more information that is usually not available. Okay, I will go back to the presentation. And in that sense, we obtain this value that and the distribution. This is very useful for make analysis of the cost structure of different hydrogen projects. We are getting to the end of the presentation, and just as a final remarks, the LNEG levelized cost of hydrogen calculator is a free tool, so anyone can use it, can access it. So if you need to estimate a value, feel free to use it. If you find a bug or a problem with the tool, please report it. In that sense, we can make the user experience better and more useful the tool for anyone. It can reproduce the levelized cost of hydrogen of other calculators, as we have seen. It can handle different components of the hydrogen value chain. That is one of the advantages or characteristics of this, and it is user-friendly. The NREL has probably included some components, but those are like master Excel sheets, and you will need a very deep knowledge in order to navigate for all these sheets, because the way they calculate it is a little bit different. What we can do with the tool, sensitivity analysis, design of business models, or confirm, okay, very quickly some values, some references, and that may be very useful for people who are evaluating, let's say, models for companies or things of that kind. And of course, we provide a set of reference values that may change in the future, of course. I noticed that the reference values that the European Commission tool that were like 1-2 months ago were a little bit updated, especially in the CapEx. And well, is that type of information that probably we will try to update on a yearly basis, or maybe every 6 months, just to verify if there are some other, let's say, updates regarding the costs and the trends toward 2030 to 2035, 40. So that was basically the presentation that we got for you today. And now, if you have any questions, please feel free to stand up, open your mic and make your questions, or write them in the chat.